So in this video, I'm going to talk about intermolecular forces and how they specifically affect the properties of water, because water is the most important solvent. So water is really unique in a lot of properties. It's often called the universal solvent because it dissolves so many things and it's so useful. Pretty much all of these unique properties of water are due to intermolecular forces, mostly due to hydrogen bonding, because hydrogen bonding is so important in water. The first property is the solvent property, which we talked about a little bit before. If you've got an ionic compound, like sodium chloride, that makes a crystal and you put it into water, it dissolves. And what this means is that the ions all come apart, and each ion is then surrounded by water. So we call this a hydration shell. Notice that the positive cation is surrounded by the oxygen side of water, and the negative anion is surrounded by the hydrogen side of water. So it's not a random thing, and this is pretty much unique to water and really important for solvation. Surface properties, we've also talked about surface tension, which is really easy to see in water. Water beads up on the surface of many things because of its hydrogen bonding. It's so attracted to itself, and that gives it a really high surface tension. If we compare the surface tension of water to lots of other liquids, acetone, ethyl acetate, ethyl alcohol, which also have IMFs, water, because it's so much has such strong hydrogen bonding, super high surface tension compared to these other liquids. The density of liquid and solid water is very, very unusual and very unique. Water can hydrogen bond in its liquid form, but the hydrogen bonds are formed and then they break and then they move around really easily. So they're always moving, and they're pretty close together. What happens when ice is formed is that the hydrogen bonds are more stable and more structured, and they're also a little bit farther apart. So water hydrogen bonds are slightly longer in ice, and what this means is that ice is a little bit less dense than water because the molecules are a little bit further apart, lower density, and that's why ice floats. And this is very, very unique to water. Most solids do not float. Most solids sink. A little bit of terminology about solutions, just so that we know what we're talking about. A solute is something that gets dissolved in a substance. A solvent is the liquid that does the dissolving. If you dissolve a little bit of something, we call it dilute. If we dissolve a lot, it's called concentrated. And we're going to talk more about these in a chapter on solutions later on in the year. We say that a solid is soluble if it dissolves, and if it does not dissolve, we say that it is insoluble. Two liquids that are both soluble together are called miscible, and if they don't dissolve each other, we call them immiscible. So this would be like oil and water are immiscible. What happens in solution, again, sodium chloride placed in water, as it dissolves, the ions are surrounded by water. What happens when a polar covalent compound dissolves? So the best example of this is sugar, and this is glucose, but any sugar will do this. Sugars have OHs, and the OHs can form hydrogen bonds with each other if it's solid, but if we put them in water, they can form hydrogen bonds with water. And what this means is that sugar dissolves in water. So if they can, if they have attractive forces for each other, then that will make them soluble. What about things that are nonpolar, like gasoline in water? So nonpolar gasoline, CHs, polar water, one of the terms that we use is like dissolves like. So nonpolar doesn't like to mix with polar. And again, this is why oil and water don't mix. Hydrocarbons like gasoline, which are made of CHs, are nonpolar, and they are not attracted to polar molecules like water. Nonpolar compounds have more attraction to each other than they do to water. So this gasoline is going to rather be surrounded by other gasoline molecules. And again, that's why oil and water are going to separate from each other. What about gasoline with propane or oil? So here we've got heptane, which is commonly found in gasoline, and then methane, which is natural gas, and propane, which is the fuel used in tanks, for grilling and things like that. So all of these have the same intermolecular forces. They're all nonpolar, so they will all be soluble with each other or miscible with each other.